Hello. In previous lessons, working with quadratic functions in vertex form, we learned how to, if we were given the equation of a function, how we come up with the graph of the parabola by shifting and stretching. We also learned if we have the graph, how can we find the equation of the parabola by working backwards from that process. And the third thing we did was we learned how to solve certain kinds of quadratic equations using the square root method. So this exercise is going to combine all three of those elements. The first is developing an equation for the graph that you see here. Then it would be solving that equation and verifying that it actually matches the graph. So that's what this video is going to cover. I'm going to start with identifying the equation for the parabola. That'll be one half of, or the left-hand side of my equation. And the first thing I do is remember that I want this in vertex form, and this is the form of all parabolic functions in vertex form, where hk is the vertex and a represents the vertical stretch factor. So I can easily define my h and k values by looking at the vertex. The vertex is 1, 2, so h is 1 and k is 2. So we have minus 1 and plus 2 for the hk. Then you have to identify another point, not the vertex, any other point. And so these graphs generously provided a y-intercept for us. Any other point will do, however, but I know for sure 0, 4 is a solution. So when x is 0, y is 4. That gives me an equation with just a, makes it easy to solve. So the square of negative 1, 0 minus 1, squared is 1, plus 2. So we have a plus 2 equals 4, which means a equals 2. So now I have h, I have k, I have a, which gives me the left-hand side of my equation. The right-hand side of my equation is just a horizontal line. We'll see where the y is. It looks like y equals 5. So that's the equation of the right-hand side. And therefore, the equation that's being represented by this graph is 5, the horizontal line, should be equal to this stuff, which is the parabola. Now, I have to show that I know how to do algebra to solve this equation, but before I do, I'm going to go over to the graph and find out where those solutions should be. The parabola has the same value as the horizontal line when x is around negative small number, so I put negative 0.2 question mark, and positive slightly bigger than 2 question mark. So I could see it's not going to be exactly at 2 because I would have to go over 1 up to get there. Anyway, so I know approximately what my solutions should be. I found the correct equation here if I get solutions that are near those numbers. So, process of solving, the first thing I'm going to do is unpeel the layers. The last thing I did to the expression on the right was add 2. So I'm going to subtract 2 to both sides. Then the second to last thing I did to my x on this side was doubled it. So I'm going to divide both sides by 2. The next thing is I squared, so I'm going to unsquare, square rooting. Don't forget, when you square root a squared variable, you need absolute values, and these are going to be the two different scenarios. Either x plus or x minus 1 equals the square root of 3 over 2, or the opposite of x plus minus 1 equals the square root of 3 over 2. In other words, we will have 1 plus or minus the square root of 3 halves. Now again, what I can do is I can estimate the square root of 3 halves. The square root of 3 halves is going to be somewhere between the square root of 1 and the square root of 4. Square root of 3 halves. And we know this is 1. And the square root of 4 is 2. So we know that we're talking about a number somewhere between 1 and 2 here. And it's going to be less than 1.4 because the square root of 2 is 1.4, so we could say maybe 1.2 or so. So as you can see, if you take the number 1 and you add approximately 1.2, you get about 2.2. And if you take the number 1 and you subtract approximately 2.2, you get negative, or sorry, 1.2, you get negative 0.2. So it all checks out. So one more quick example, just to demonstrate how simple this can be if you do the practice. I'm going to identify the vertex and one other solution on the graph. In this case, it's the y-intercept. So I've got the vertex and the point 0, negative 8.5. So I substitute all those values in for h, k, and x and y to solve for a. That gives me an a value of negative 3 halves. And just verifying, it should be negative because the parabola is opening down, and it should be bigger than 1 because it appears that there's a stretched out parabola here. It's not over 1, down 1, it's over 1, down a little bit more. So that's consistent with what I see on the graph, so I will move forward. The line here is y equals 2, so the equation represented by this graph is the line is equal to the parabola, and I solve using the same techniques as before. So don't forget, we unpeel the layer, so we subtract 5 from both sides. We multiply by negative 2/3 on both sides, giving us 2 here. Square root both sides, separate the absolute values, and recombine. Finally, you estimate those values based on your knowledge of known square roots. The square root of 2 I should know is around 1.4. So when I add and subtract that value from negative 3, I get these two values, and I go over to my graph and verify that those are in fact consistent with what I see. So that's the whole process. I hope you found this helpful. You can look on the Power School Learning to find out more practice. Also, just a quick little observation here. In both cases, I can't remember if I showed it or not in the last case. Yes, I did. I can go to Desmos. It's really important that you do that for this set of exercises because I have to make sure that my graph and the Desmos graph actually look the same. The reason for that is I could do all my algebra right here, but if I have the wrong equation, I'm going to have the wrong solutions too. So to verify that your solutions are correct, you use the given graph, but to verify that your equation is correct, you're going to want to check Desmos to make sure that that's consistent. So that's what I did here as well, except I superimposed it on my graph just to show how perfect my graph was. Anyway, thanks for watching. Have a great day.